Hello dear student, this is Devang Shah from LG Institute of Engineering and Technology. We are going to discuss about the characteristics of AC signal. So our today's topic is phasor representation of an alternating quantity, right? So here, if we look for a phasor representation of alternating quantity, where we already know the difference between the DC signal and AC signal, where DC is a simple scalar quantity, while this is not case with the AC, because AC is the vector quantity. So in DC there is only a magnitude and the current will flow unidirectional forever, but this is not case for the AC signal, as AC is a vector quantity. So in vector, the magnitude and the direction of this vector is also important, right? So once you are going to add or multiply or subtract or divide this quantity, you need to go for a kind of phasor diagram. So today's session, let us discuss about this representation, where how you are going to represent vector quantity for a AC signal or for a AC circuits, right? So let's say here you will find the even is equal to em1 into sine theta. So in our previous lecture we have discussed about the generation of AC signal, and at the end we found E is equal to em sine theta, or E is equal to em sine omega t, right? So the references start from the angle 0, right? So that particular equation represents the alternating quantity, represents the AC quantity. The same way, if we want to understand the phasor representation, then we have to take more AC signals within a same reference. So now I am taking my reference as E1 is equal to em1 sine theta. With this respect, if I am going to take another signal that is related or that represents as E2 is equal to em2 sine theta minus phi 1, let's say. Same way, if I'm taking the third signal E3 is equal to em3 into sine theta plus phi 2, right? So if I want to represent this in terms of the waveform, you can say here there is a sinusoidal signal of E1 having the magnitude of plus em1 in positive half cycle, minus em1 in a negative half cycle. Now since this is a full cycle, you can consider the particular signal starts from angle 0, right? Again it will come to 0 at angle 180, which is a pi, and again it will come to a magnitude is at 0 at angle the 2 pi or 360. So this is a full cycle of reference signal E1 is equal to em1 sine theta or sine omega t, right? With this respect, if I'm going to plot the another signal E2, that is equal to em2 sine theta minus phi 1. Minus phi 1, that means this particular signal E2, which is a sinusoidal signal or which is a AC signal E2, starts after the angle 0, but it starts at angle phi 1, right? So this angle starts later on. So I can consider this signal actually is lagging from the signal E1. Same way, E3 that starts early at before the angle 0. So I consider that is at the angle phi 2. So I can say here E2 is lagging by angle phi 1 with respect to reference 0. Same way, E2 is leading the angle phi 2 with respect to angle 0. Right. So here my reference signal E1 is equal to em1 sine theta. It's a plus or minus angle 0. So this is what my reference is. With this respect, if you find, if you describe this particular theory as a phasor representation, right? So since this is a AC signal, this is the waveform. Now I would like to plot the phasor diagram of these three signals uh, which we have taken as a reference. So now this is the phasor diagram of E1, that the particular vector starts at the angle 0, right? Now how this particular vector starts at the angle 0, that we will discuss in a minute. Just this is the vector representation of only signal E1. You can see this. Now as such, the angle phi 1 starts after the signal E1. You can consider now why this angle is see, this angle is represented as minus phi 1 with respect to angle 0, right? But it starts later on. Why? Because these two vectors are moving in an anti-clockwise direction. So first vector starts at E1, another vector starts after E1, that is E2, with the phase difference of phi 1. Now the third vector, it starts early before the reference vector E1, that is the vector E3. You can see here now all these three vectors are moving in an anti-clockwise direction. Once it moving in an anti-clockwise direction, so the first is E3, then you have a E1, and then you have a E2. All these three vectors are moving in an anti-clockwise direction. Now, how, once you want to imagine this, how these vectors are moving in an anti-clockwise direction, what is the terminology? So that terminology we have already discussed in our previous lecture. So you can see this here. There are two magnets, and in this two magnets there is a rotor, or there is a conductor which is moving in anti-clockwise direction, and this will generate EMF, this will generate AC signal, right? So since here in this diagram we have only one conductor, but now you assume that there are three conductors and they are placed like one conductor at angle 0, another conductor at angle phi 1, and third conductor at angle phi 2, and all these three conductors are moving in anti-clockwise direction like here. So you imagine this particular phasor diagram, this particular vectors are moving in anti-clockwise direction between two magnets, right? So this is what the phasor representation of any alternating quantity. Now, what are the different methods to represent these vectors? So here we can consider there are two important methods. One method is called the graphical method, and another method we define as an analytical method, right? So now this is very important because you cannot straight away simply do the addition, subtraction, multiplication or division of these quantities. It's not like 2 plus 3 is equal to 5. Why? Because this particular quantities are a vector quantities. So it includes the magnitude as well as the direction, right? So at the end, the resultant of magnitude always depends on the direction of this vector, right? That's why you cannot apply a simple arithmetic addition, subtraction or other operations for this vector quantities. That's why we have to follow these two particular methods. One is called the graphical method and another one is called the analytical method. Let's discuss this. So in graphical method, you can see here the step by step. If you see this, so first we have to take define a reference vector like just we have discussed. So here choose one of the suitable vector as a reference and draw it on a x-axis. Now all other vectors be added having their own phases. So we can consider this is one of the vector will start at the angle 0. Let's say it's any reference angle, and that vector we define as the magnitude of this vector we define as Im1. Same way, I am taking now another vector with reference to the first vector. So draw the remaining vectors one after another and considering that individual phases. So I am taking another vector is having the angle theta 1 and magnitude is Im2 with the respect to the first one, and with respect to the second one I am taking my third vector is representing the magnitude of Im2 with the angle of theta 2. Now there are three vectors. As such, this is a graphical method. So your resultant vector is always connecting the first point with the last point. So you can see here, join the last point with the origin to complete the vector, this polygon. You can see this. This is called my resultant vector, right? So this is nothing but between the two magnet. If I am putting three vectors and they are all these vectors are moving in anti-clockwise direction with the magnitude, with the individual magnitude and with the individual phases. Once I'm going to find the resultant vector, and that resultant vector is nothing but the joining of origin to the endpoint. So here you can see the length of this vector from the origin to the last point represents the maximum value of this resultant quantity, and that is called my IR. That is called the resultant magnitude of the current with the angle theta. So here we can define the angle theta like the angle made by the resultant vector with respect to the reference is the phase of the resultant quantity. Now this particular method we define as a graphical method, right? Now normally this method we are not much using, but instead of this method we are using the analytical method. Analytical method is simply based on the mathematics where you need to discuss about the Cartesian representation of the vector as well as the polar representation of the vector. So you can see here my current vector I is equal to Im sine omega t plus theta. Right now, this particular AC signal or this particular equation, if I want to plot using the graphic or in a graph, so you can see here the rectangular coordinate I consider as x plus jy, where x is the real quantity and y is the imaginary quantity, right? That is associated with the j. So here, if I talk about only the x, the real quantity of this vector of this AC signal I is equal to Im sin omega t plus theta, then x is related with the cos component and y we represent as a sine component, right? So x is equal to Im cos theta and y is equal to Im sine theta. These are two vectors. One is a real and another one with a imaginary. So always remember x-axis is related with the cos factor and y-axis is always related with the sine factor, right? So if we define this particular term in a polar, so that coordinates is I is equal to Im having the angle of theta. So you can see here in this particular figure where r and theta, so the resultant vector you can see with the red line which is the resultant vector r and having the angle of theta, right? But the x and y component you can see here, these two coordinates, so here x is represented as Im cos theta and y is represented as Im sin theta, right? Part of the trigonometry, then I can write my total I, that is equal to Im sine omega t plus theta, that in analytical representation I define as a I is equal to Im cos theta plus j into Im sin theta. So that representation is nothing but a kind of Cartesian or rectangular representation. You can see the rectangular shape here. Same with exponential coordinates, if you want to find, then you can find like I is equal to Im e raised to minus j theta, right? So this is just a mathematical terms. Now the same thing if you want to take as an analytical method, you can see here you have total two components, x-axis component and y-axis component. So so far if you have any particular equation like I is equal to Im sine omega t plus theta, then my first job is to find x component and y component. X component I can find from x is equal to Im cos theta, and y component I can find like y is equal to Im sin theta. Right now, taking the resultant vector, so I'm going to take the resultant value that is equal to under root x square plus y square, and the resultant angle that theta is equal to tan inverse y by x. How by this method you can find analytical values of any AC vectors or any AC quantities. Now you can see here there is a rectangular shape where there are two axis, x-axis, right, and you can consider here the y-axis, but here see the x I can represent one of the value is, let's say V2 is equal to 30 volt and V1 is equal to 20 volt, right? These two values where x is represented as a cos and y is represented as sine, right? So once you use the parallelogram method, diagonal is represented as the resultant vector. So here my diagonal is nothing but total V is equal to V1 plus V2 and having the angle of theta. So here the resultant value of the vector in terms of the magnitude, that is nothing but the resultant value is equal to under root x square plus y square, and the resultant angle with the reference vector is theta is nothing but equal to tan inverse y by x, right? So based on this we can also discuss more examples later on. So by this representation we can understand if you want to represent any AC quantity, you can represent by two methods. One is called graphical method and another one is called the analytical method, right? So you further discuss about this, and let's say in again after this method you can represent any AC signal. One way of representation is called a polar representation and another way of representation is called the rectangular representation. So the by which way you can convert one form into another, you can state from this equation like to convert from polar to rectangular, you have to use x is equal to r cos theta and y is equal to r sin theta. Same way r is nothing but the resultant vector. Same way, if you want to convert from rectangular to polar, then that means we have just discussed about the analytical method where r square is equal to s square plus y square and tan theta is equal to y by x, right? So this is what the common equation. Later on, once you have a numericals and you have a vector quantity, at some moment if you want to add, subtract, multiply or divide, in this situation you have to either convert into a polar form or either you have to convert into a rectangular form, right? Thank you, dear students. If you have any doubt, you can write in my comment box. Thank you very much.